Hello, and welcome to the Aether Community Meeting. Thank you for joining us today. Now I'm pleased to introduce you to our guest speaker today from CPQD, who will discuss the initiatives underway for which they are using Aether. Daniel Lazkani Pfefferman is the telco cloud architect at CPQD, where he works with open source tools to increase mobile connectivity. He holds a Bachelor of Science degree in telecom engineering from UFF and a master's in electrical and computer engineering from Unicamp. He received a fully funded scholarship from the Brazilian government to study at the New York Institute of Technology and previously served as a researcher at the Illinois Institute of Technology. Daniel, welcome. Please take it away.
Hi, everyone. So I'm sharing my screen. Okay, so my name is Daniel. As Denise said, I work at CPQD right now. I would like to first thank you, Denise, for the introduction and all the ONF and Intel team that has been helping us with the Aether to develop over to the community. So let's move on to the agenda. So what we intend to present here is basically who we are as CPQD. Our project, so we do have, we are working with two projects with Aether. So the first one is Open Run Brazil, and the other one, we call it Plat5GBR. It's an acronym, we're gonna talk later. And then we will discuss a bit of our lesson learned using Aether and maybe some ideas. And then we will present a bit of our demo that we exposed in the beginning of this month at the OEI conference. So talking a bit of CPQD. So CPQD was founded back in 1976 as a research R&D center of Telebras, which was a national public telco operator by then. In 1998, it became a private nonprofit organization, meaning that any type of profit is reverted to R&D investment. It is the largest ICT R&D program in Latin America, with a revenue of 229 million BRL in 2019. This is a bit not so new, but and we do have a presence in all telco operators here in Brazil and some others Latin America telco operators too, with our OSS suite. We are a certified lab for compliance and testing in Brazil, Anatel. Our lab is part of the TIP community lab. We have a Brazilian branch of, we are a Brazilian branch of the BRICS Institute of Future Network Initiatives, with a deep knowledge of local regulatory frameworks here in Brazil. We are a total of 900 collaborators with 360,000 square meters and 352 patent processes and 172 international patents. We have clients in Brazil, Uruguay, Argentina, Chile, Peru, Ecuador, and Colombia. So, and lastly, we do have like two spin-offs companies that came from CPQD, which is Tropico and PadTech. So this is a brief introduction of who we are. Talking a bit more into the telco environment and some other areas that we work on. So in the left side, we see the CPQD headquarters in Campinas. We can see we work with indoor and outdoor GNODEs, and some of our area of knowledge include cognitive computing, advanced computing, wireless communication, optical communication, data network, sensor systems, power systems, embedded electronics, and information and communication security. Basically, now talking more deeper about our projects. So a bit of introduction of each one of them. So we are using Aether in 2 projects, as I said previously. One of them is Open Run Brazil, and the other one, it's called Plataforma 5G BR, which is we use the acronym as a Plat 5G BR. Both are funded by the Brazilian government. The Open Run Brazil is a partnership between CPQD and RNP, while the second one, which is the Plataforma 5G BR, it's just CPQD. Just a brief introduction about RNP2, as they are our partner here at inside the Open Run Brazil project. RNP is an advanced national network for higher education, research, and innovation. They brought the internet to Brazil in 1992, and they continue to promote innovative ICT targeting science and education for everyone. They are connected to international academic networks in South America, North America, and Europe. Their infrastructure is composed of 27 points of presence all over Brazil, each one in a state in Brazil, and branches of more than 1K campus and units of education, research, and health, benefiting millions of users, 800 connected organizations, and with more than 100 gigabits per second of speed. Talking a bit about the Open Run Brazil, so the project is a project funded by the Ministry of Science and Technology in Brazil. The main target is to build a testbed with the following objectives: to develop and bring a testbed to new technologies and use case, as an example, a 5G application. Using state-of-the-art technologies that we are using, including O-RAN, SDN, 5G. Of course, currently we are using SD-Core, and to learning environment too. So, and also as a lab test to new technologies like a multi-domain orchestration, which we are currently using Aether, XApps, and other possibilities. So lastly, it's a space to promote the development of O-RAN solution using 5G applications. Another project that we do have is the Plat 5G BR. The main target of the project is the development of 5G network technologies for private network markets, from small to medium providers. We consider a 5G system composed of state-of-the-art technologies, including orchestration, automation, and virtualization. Lastly, we consider that currently the market is more focused on the eMBB, which of course increases the throughput, but we are also looking at opportunities on the IoT market and ultra low latency too. Continuing, so we consider, okay, so how we're gonna do this? We consider that by the development of 5G core and integration with a RAN through virtualization and disaggregation, using the Open RAN, the open standards, considering the O-RAN Alliance and the TIP2. Another important element for the solution is the automation of the platform, simplifying the creation of the operation and the monitor of the 5G network. We are currently testing and using Aether for this activity. Lastly, our main target is to construct a proof of concept for private and ISP markets, integrating with all the developed functionalities. So just a few words here for the Plat 5G BR. So one of the targets is Open RAN. So we understand that we need open interfaces, distributed cloud architecture to aim resiliency and high availability, MAC to improve latency and throughput, IPv6 to, as we all know, IPv4 address is scarce, and we need to be ready for the next generation of IP. SDN as a centralized control plane improve network intelligence and automation. Simple and scalable infrastructure with capacity to auto-scale. Edge-to-edge infrastructure automation to deploy the network from day zero. And a unified OSS BSS to simplify the operation and business support. So this is one of the setups that we have done with the Plat5 GBR. Some of the achievement here, we got virtualized to run, which is BiCells, connected to a high-performance 5G core with DPDK support and with support to multiple slices, and using Aether APIs as the orchestrator. So we got this full setup from the UE to the Gnode B as a all-run solution, and to the 5G core with the orchestrator using the APIs of Aether. So we have tested Aether with 3 physical runs. One is OAI, the other one is OAI with USRP V210. We're going to talk later as a demo that we exposed it in the beginning of this month. The other one is a Matisoft to test and troubleshoot inside our lab. And lastly, BiCells, which we can get a more throughput experience. So we have tested with Viper, with UDP, and we got the downlink of almost 1 gigabit per second with a single UE, of course, and an uplink of 138 megabits per second. So this is just exposing it. And getting to the lesson learns, basically, we started this in the first semester of 2022. And we got a learning curve between it. So some of the things that we understand is how the architecture, so how Aether in a box is connected. So this is something that we understand it's interesting. We need to have an architecture of it. So in the beginning it was really hard to get on it because we were not understanding how everything was connected, how it works. So the way that we got through it was to check the routes of each one of the elements. So Aether in a box uses access and core as N3 and N6 using the MacVilla interfaces. So and to troubleshoot, sometimes we may get some problems. There is like a BAS graphical user interface, which sometimes can help us to troubleshoot and to understand what is going on, which part of the connectivity we are getting and where we are missing. Lastly, we have been contributing back to the community by identifying some bugs and some documentation issues. We have been really close to the ONF to test it on real scenarios and emulated scenarios. And it has been a really nice experience. Once again, I would like to thank all the support from the ONF and the Intel team that has been helping us to get on it. And lastly, this was something that we exposed in the beginning of this month, November, where we got a full setup using Aether as the orchestrator and SD core as the 5G core, connected to a USRP, which is OAI, which is running OAI, which is connected to FlexRig to get the KPIs of the Gnode B and to expose it in a Grafana. So this was a really nice work that we have done. We connected this to a real UE. And to make it, I promised in the beginning that I was going to show a demo. So to get on it, we got like a video about it. So let me get here. Okay, so it got better. So we started with a UE that it was on airplane mode. And in the right side, we got the Grafana, which is collecting all the KPIs. So we removed the airplane mode, and then we start checking the Grafana, which gets updated. And then we can see the modulation for the uplink and downlink and the throughput of it. So we got the UE connected. We are monitoring it. So everything with telco start with a ping, right? So this is what we are doing here. We are testing the connection. We can get to the DNS of Google. It's working. It seems good. So, but ping it's not enough, right? So let's go to something more complex. So we start with a speed test to check if our connection is good. So we are using USRP. Of course, it won't go to 1 gigabit per second, but we got a good throughput, and we can see on the right side that the throughput got a peak, and the peak it's updated almost to 80 megabits per second, which is right the result that we got from the speed test, right? So we can see that there is like a peak of it, and then it goes back to zero because we are just doing a throughput, a fast throughput test. But okay, sounds good. But this is just a throughput test. Let's go to a more what else can we do? So let's open a YouTube video. Unfortunately, we do have like some ads from YouTube. I'm gonna just skip from it. We can increase the screen too. So what we're gonna do is right now we got Aether with 500 megabits per second. So this is how it is set. So we're gonna put the resolution of it to 2K, which is the maximum that the cell phone can get. And we're gonna put it like 2 times faster to make it even more throughput, asking for throughput, let's say. So we got a throughput near 30 megabits per second. Let's wait a while to check if it's working fine. So we can see the video is working okay, no problem. It is steady. We are not getting stuck for any reason. And then we just change the slice from 500 to 1 megabits per second. We go to the basket. We just wait a little bit to check. The downlink is being monitored by the Flex rig, checking the G-Node B. So it's getting near 30 megabits per second. We're gonna decrease it to 1 megabits per second. So when I click commit, it's gonna ask if I'm sure. I'm gonna put it okay. It's gonna apply it. And right next to it, we're gonna see the video, and it's stuck. You can see that the video stopped. It's not working anymore. And it's not just not working, the throughput is being recalculated. And we got like 1 megabits per second as we put it. So using Aether, we were able to decrease and to set up the limit for the slice. And we can see the limit is really near what we put it. We put like 1 megabits per second. We are getting a little bit of difference. This is probably due to the layer of the RAM. And then we can just, after a while, we can see that the number is still fixed right next to 1 megabits per second. And we make it ready to do a rollback, to put it back to no limitation, which is 500 megabits per second. So we put it commit and then press OK. And then the video is back, it's working, and we can see that the downlink is once again increased to 40 or 30 megabits per second. So that's it. That's it. And basically, I'd like to thank everyone. That's it. Denise?
Thank you. So thank you for your presentation, Daniel, and would like to invite our attendees to ask any questions. Please use the Q&A module at the bottom of your screen if you'd like to type in a question. Siva, if you'd like to join Daniel and perhaps get the discussion going.
Yeah, happy to do that. Daniel, that was a pardon me, great demonstration. I really appreciate that. We don't no questions yet, but let me ask you a couple leading questions. How is CPQD deploying their services? Who are the end customers or end users for these capabilities?
Sorry, Siva, I didn't get exactly what do you mean?
So who are the customers using these mobile services, these wireless services? Who are you deploying it to, and how's it being used?
So right now we are using internally. We are getting more used to it, and we do have some users interested on it. We are just waiting a bit more. Okay.
Gotcha. And if you were to try and do the same sort of setup with commercial equipment from commercial vendors, what's the rough cost differential?
So to get the setup that we put it here in the slide, the demo that I just exposed it, we can get this with around 7-8K USD should be enough to get all this setup from edge to edge.
And that's for the Aether and the buy cells and that like?
Yeah, you can set up Aether with really low requirements. To just test it, you can do Aether in a box. You can do with really low resources. You don't need to have a server. You can do it in a laptop. So from our experience, we were able to set up with 3 CPUs of an i7 with 8 gigabytes of memory. We were able to set up without a problem.
Great. Okay. Question from one of the guests here. Are you using DPDK mode with the Aether UPF?
So yes, we are using DPDK. Some of our results here, they are not with DPDK. We are still stressing a bit of it. But yeah, we already tested with DPDK with a Broadcom networking card.
And what sort of challenges did you have to overcome to use DPDK mode?
So regarding the DPDK mode, we got some challenges. First, it was at least from the previous experience from the ONF and the Intel team, is that they tested with Intel and with Mellanox, but not with Broadcom. So we got some difficulties with the plugging and some drivers for the Broadcom environment. So this was one of the difficulties. The other difficulties was because of the setup and the configuration for the DPDK. It's a bit more complex. So we got some steps that were different, but yeah, they are feasible, of course.
Right. Okay. Good. I got a question from AJ. Actually, AJ, you want to jump in and ask a question?
Hey, hi Daniel. It was nice presentation. I wanted to know more about the OAI G-Node B, which you have shown in one of the slide.
Yeah, we are using the B210. So we do have others. We are still getting. It's a new one that we just got. But right now we are using the B210 was one of them. So the one that we presented in the demo was this one, B210.
So it's shown in the PC one. So it's like complete software that the
B210,
not the USRP one, the one which is inside the box, the open air interface, OAI G-Node B SA. Yeah.
Yeah, everything that is inside the PC one, they are software based. The only thing that we are using, so the PC one, it was like it was an i7 laptop, and we brought to the conference. The PC2 was another laptop, i7 too, and the USRP was a hardware separate that we connected through the USB cable to the first PC. To get the G-Node B using the OAI software.
Okay. Yeah. Thank you.
All right. Thanks, AJ. Eric had a question regarding, did you try the hardware UPF? And if so, what was the performance differential?
Yeah, I believe by hardware UPF, we are talking about the P4, right?
Yes.
No, we did not test it yet. It's something that it's in our roadmap. We are already getting in our lab a P4 UPF, but we didn't test it yet. We're
Gotcha.
still in the roadmap to get it.
Okay. Mohammed Abdel Hafez, hopefully I pronounced that correctly. What are the hardware requirements for the radio part?
Yeah, so for the radio part, basically and theoretically, anything that it's 3GPP should be working. From our experience, we have tested with OEI and Bicells, Open Run, and Amarisoft. But theoretically, others should work too. I know that ONF already worked with Sercom and others too.
Yeah, and I think we also like to create a marketplace where people can get tested and approved, not so much tested hardware, so that there's known interoperability as opposed to having to figure everything out from scratch.
Like certify it.
Gotcha. AJ, you got lots of questions this morning. Jump in with the next one.
Yeah. So I'm more interested in knowing how you are like trying to expand your phone support base, and what kind of SIM cards you are using, because we find it hard to get the SIM card writer for 5G.
Yeah, so there are some phones that do work with 4G SIM cards, and others that do not work. This is a limitation from the vendor perspective. So some vendors consider like a security risk to work with 5G using a 4G SIM card. But yeah, it is possible to get it. We have stressed this with 4G SIM cards. And there are a couple of devices that do allow to work with 4G SIM cards. And at the same time, yeah, we got some SIM cards from the market that are 5G too. So we got some good market vendors that got us some of them. But as I said, you can always use the 4G SIM card if you use the right UE as to test it.
Yeah, so is it possible to have those SIM card access to other community members if they're ready to purchase it? So like we have found it difficult to make it iPhone work because iPhone doesn't allow test PLMN, or it doesn't take 4G SIM cards for at least 5G network. Yeah.
Yeah, so my suggestion to this case is basically to get a 5G UE that do work with 4G SIM cards. I believe it's going to be easier because in the market there are a couple of them, and they are not the most expensive ones. So the Motorola that we use it's not really expensive. So I believe you probably in US you can get like with less than 200K. 200.
Oh yeah, I mean in ONF we have Pixel phone working with the 5G G-Node B and as well as the Moto 5G, but we are just trying to see how we can expand the phone support. Yeah. Okay.
Yeah, for iPhone specifically, we would need the 5G SIM cards, and to be honest, I would need to check internally how we could get it.
Yeah, thank you.
I'm curious, just to kind of follow on to that one, Daniel. What frequencies or bands are you using in Brazil for this network?
So in Brazil, we are mainly targeting the B78, which is the 3.4 or 5 gigahertz. So we are more using this. Of course, we do have others. Like the N28 and other ones, but the main one is the 78.
And have you found any issues with mobiles not supporting those bands, or finding the intersection of where the bands where the phones work on the bands you're using?
No, to be honest, the 78 and the 28, they are really all the devices that do say that they allow 5G here in Brazil. From my previous experience, all of them they were compatible to both
Okay.
frequencies.
All right, good to know. Eric asked a question, and I'm going to read it literally, and then I'm going to rephrase it a little bit. He said, "What, if anything, do you not like about Aether?" But I think the better question maybe, what are some lessons learned that you can share with people about both the good and the bad about Aether?
Yeah, so the lessons learned is that I do have experience with open source 5G and 4G core. And what I can say is that different from some of the common ones like Open 5GS and Free 5GC, the learning curve is a little more complex. So this is something that I would say that this is the downside, let's say. But the good side is that we can get like a full Kubernetes environment, and the possibility to run with DPDK and P4 for a higher telco grade solution. It's really nice. One other thing that I believe it's kind of the downside too is that unfortunately, as the core, it's a bit new to the community. So we are still getting a track on it. So we are still getting power to go to the next level, to the next roadmap and new features. So compared to some of others, Open 5GS and Free 5GC, there are some elements that we still do not have here. But on the other side, as I said, it's a more telco ready and more resilient solution, considering that it's using Kubernetes and we can have high availability, and we are working with auto scaling. So we are getting on it. This is my understanding.
Okay, great. Aditya wanted to know the full model name of the Motorola 5G phone that you're using. And
I cannot say by heart. So we need to check this one.
we'll handle that as a follow-up then.
Yeah.
Okay. One of the questions we get quite often from an ONF perspective is, how difficult is it to use your software, and how long did it take you to kind of get up and running and working with it and getting some successful results?
Yeah. So I would say that using Ether in a box was not so hard. So it took some time, at least to know the architecture. As I said, after it, everything went pretty good. But I would say with Ether in a box, maybe you can do from the first time it's gonna work, but maybe you're gonna need to troubleshoot a bit. This could take like 2 weeks, maybe 3 weeks. And then to go with more complex solutions using Ether standalone and other ones, it would take a bit more. It would take like 2 or 3 months.
Gotcha. And does that include using physical radios, or did you actually start with RAN simulators?
So yeah, when we started, we used it RAN simulator. We use it. Re-rancing is another one that we didn't put it here, but yeah, we started with it. We have done it in 2 scenarios. One of them with a different VM using re-rancing, and the other one with Ether in a box. And we have done it in both all together in the same cluster. So it is and you can have like a diverse type of solutions, right? You can have a single laptop with everything from the re-rancing to the 5G core and to the orchestrator. So you can get this setup. This could take a while to get on it, but you can get this, or you can split them in 2 VMs, which should get more performance too. So you can get more realistic. So with re-rancing, we got 1 gigabits per second with DPDK as an example.
Right.
This is something that we have done a few weeks ago.
Gotcha. Okay. Thank you so
Thank
much. I appreciate you answering people's questions, and I'll turn it back over to Denise.
All right. Thank you so much, Daniel. That was a terrific presentation. A lot of great insights you shared with us. And thank you to everyone who joined us today. We invite you to attend and participate in upcoming Aether community meetings. The next one will be in January.